Hello and welcome back for another composite problem. And now we are into the three-dimensional composites. So we did 3 problems with the two-dimensional shapes, and now we're up to the three-dimensional composite. So this first one is a combination of a sphere, half a sphere, and a cone. So this looks very much like an ice cream cone, a lemon ice cream cone. So for the ice cream portion, we're going to assume that it stops right there. It doesn't go down into the cone at all. And then for the cone part, we're looking at a conic shape. So we'll need the formula for the volume of a cone and the volume of a sphere. And I do not remember these. I don't work with them very often. So we're going to need to go back into the notebook and find the formulas for me, because I think I know them, but I'm not positive, and I don't want to take a chance on missing it. Also want this to be a lesson for you to always look up the formula if you don't know it for certain. So these are solids. I'm going to go back to the solids section and just scroll through until I find a cone and a sphere. And as luck would have it, they're on the same page. So I'm going to copy this just so that I don't have to remember it. My memory is not what it used to be. So let's go back to composites and over to our ice cream cone. And I'll paste those formulas in just long enough to write them down. And then I'll get rid of that part. So the cone is V equals 1/3 pi r square h. I actually did know that one, but I could not remember the sphere. I never work with spheres, so I never work with cones anymore. I don't do these problems like I used to. Okay, so let me erase this part, and I'll have to actually cut that sphere out because that's an image file. Okay, so we need to do half a sphere and a full cone for this particular composite. This is a three-dimensional composite, so the formulas are a little bit harder to do. And I'm going to start with the cone. Even though that's the longer of the two formulas, I don't have to cut the cone in half. I can just do the straight up formula. So I'm going to say V equals 1/3 pi r square h. And any time we're dealing with circles, we will have to deal with pi. So pi is constant. Remember, way back in the beginning, we talked about where pi comes from. And so if you need to review that, it's back there, but pi is constant. The radius of this cone is 10 centimeters, and the height is 15 centimeters. So again, if you are very good with your calculator, you can go ahead and type this in. I would simplify it one more step because this is a place where errors can occur. So 10 to the second power is 100. And then bring down your other stuff and multiply using your fraction key. So I have no idea in my head. I'm going to say 1ABC3 times pi times 100 times 15 equals, and so the cone part, the conic part of this problem is 1570 cubic centimeters. So the cone part of this composite is just over 1,500 cubic centimeters. Okay, let's do the sphere part. So we have V equals 4/3 pi r to the third power. Remember that exponent for the sphere is to the third power. So V equals 4/3 pi. The radius is 10, and that's to the third power. Now in the cone part, it was to the second power, so be careful here. This one requires 3 of them. So 10 times 10 times 10 is 1,000. And then you have pi, and the 4/3 you just type in as a fraction. There's nothing weird there. 4ABC3 times 3.14 times 1,000 equals. So the volume of the whole sphere is about, I'm going to go ahead and round there because of all those 6's. I don't even want to write all that down. Whoa, that eraser is enormous. So let's go back, and I'm going to say that the volume of the whole sphere is approximately 4,180 cubic centimeters for the whole sphere. But remember, we don't have a whole sphere. We are assuming that we only have the half that we can see. So we're going to have to divide that number. So 4187 divided by 2, or you can multiply times a half. I'm going to show you that because that's what I've been doing. So 4187 times 1/2 is 2,093 and a half, which is the same as 2,093.5. And remember, the title of this module is Composites. So we are going to have to take the volume of the cone plus the volume of the half sphere and combine those. So here's my last step. 1570 plus 2,093 and a half. Now if you line those decimals up, you can do this in your head. If you don't, I would recommend that you use a calculator. I'm going to check myself because I always make mistakes. I don't do math in my head very well, so don't risk it because of something like that. And this is cubic centimeters. So the final composite volume of this ice cream cone is right there. Tough problem. That one took me almost the whole page because I write very large, but several steps. These are going to be harder problems than what we're used to sometimes. Okay, I will see you in the next video for the next solid composite.